In the third part of my discussion of environmental protection framework, I want to try to apply some of the concepts we've been talking about to the study area itself. And I want to talk about four sets of values that we can identify in the study area so we can build them into our regional landscape planning process for the Lake Town Township study area. These are prime agricultural land. There is a significant amount of agricultural industry still existing within the study area. Aggregate mineral, sand and gravel resources. Down along the Minnesota River, there's an extensive supply of sand and gravel resources that are quite valuable to the Twin Cities in terms of new highway construction and home construction. Also, there are a significant number of recreational and open space resources associated with such things as the Carver County Reserve and other parks and open space systems. And finally, I want to talk about the scenic value and how do we go about assessing scenic resource values in the landscape. In terms of assessing agricultural values, one of the things that we use very intensively is called the Soil Survey Manual. These are manuals that are produced for each county. Most counties in the state have a soil survey manual. They're produced by the United States Department of Agriculture, and they are a compendium of information about soil within a given county. The process is that the USDA maps what are called soil mapping units. They are defined on a aerial photograph, and then once they have some sense of what kinds of soil resource exist, then they have soil scientists and planners evaluate those resources and produce tables that interpret the potential for using the soil for different kinds of purposes, agricultural as well as other forms of uses. And they provide a really nice narrative description of the soil. There are soil survey manuals for most counties in Minnesota, and for most counties, they're available in digital format. Fortunately for us, they are available for Carver County. And several years ago, I was able to acquire those resources, those data, and so we could use them in class. So the soils data for the class are available and have been compiled from the Carver County Soil Survey Manual. In producing the soil survey manual, the first thing that's done is the soils are mapped on aerial photographs. As I'll talk about in just a minute, soils are a product of several different processes. The effect of those processes by somebody with a trained eye can actually be interpreted in terms of the topographic conditions, in terms of and cover conditions. So we can actually begin to map soil characteristics in the landscape, based partly upon the image that they generate in an aerial photograph. Soil mapping units are the basic unit of analysis, and they are a unit, a geographic area that is defined on the basis of slope and soil series. Slope refers to how steeply sloping the land is, ranging from essentially A slopes, which are 0 to 2% slopes, ranging through those that are 3 to 6%, 7 to 12%, and so on, up to slopes that are greater than 25% slope. Remember that slope is rise over run, so a slope that has as much rise as it has run is a 100% slope that is a diagonal line. Soil series then talks about original geologic parent material, the material in which the geologic material within which the soil evolved over time, and that's modified by the kind of plant community in which the soil evolved. So we can define geologic parent material organic matter, pore space or airspace in the between soil particles and water as the four constituents of soils within Minnesota. So parent material, what is the geologic parent material in which the soil evolved? In what kind of organic matter did the soil evolve? How much pore space or airspace exists within the soil? And how much of that pore space is filled with water? These are the four parameters that affect the definition of soils. Except in southeastern and southwestern Minnesota, parent material comes entirely from glaciation, from a period of time of roughly 100,000 years ago to somewhere around 10,000 years ago, most recent epoch of glaciation. Most of the state, then, the geologic parent material is a product of glacial activity. There are 5 factors that affect soil formation. First is time. The longer the soil has to evolve, the more it's going to change over time. The climate in which the soil is evolving, whether it's a tropical humid climate or an arid cold climate or a hot arid climate, is going to affect the rate at which chemical processes in the soil occur. The nature of organisms growing in the soil, either living in the soil as animals or growing in the soil as vegetation, will affect the characteristics of the soil. The topography, the extent of slope that exists in the landscape affects definition of soil, and as I said, the geologic parent material. In Minnesota, it turns out that really only organisms, topography, and parent materials make a difference in terms of the soils that we have. And there's a very clear reason for that. Most of the state, most of Minnesota, has only been out from underneath ice for the last 20,000 years. And so there really, in terms of geologic time, there really has been no time at all for soils to evolve in Minnesota. Secondly, the climate is of one type. It's cold. And relatively speaking, compared to other climates, for example, in South Texas or the Pacific Northwest or the northeastern United States or the southeastern United States, we have a very uniform climate. It's cold and it exists uniformly throughout the state. The types of vegetation in which Minnesota soils evolve are threefold. The northeastern corner of the state evolved in coniferous forest, evergreen forests, spruce, fir, and pine forests. And these kinds of vegetative material impart certain biological and physical qualities to the soil, principally through their root system and through litter that falls from the trees, leaf litter, branch litter, and so on. Deciduous forests also exist in the central part of the state and the southeastern part of the state. And then prairie soils existed in western Minnesota, southern Minnesota, and southwestern Minnesota. And as you can see in these 3 diagrams, the soils underneath of those 3 vegetative types are quite different in terms of the depth of the soil and the chemical characteristics and the biological characteristics of the soil. In grasslands, for example, we tend to have prairie soils that have very deep topsoil, very deep A horizon, as much as 30 centimeters deep, and in some cases down to as much as 6 or 8 feet deep, wherein the prairie grass roots will penetrate down to the bottom of what's called the A horizon here, and have a lot of biologic material in the soil column itself. Deciduous forest soils, on the other hand, tend to have a much more shallow A horizon, and the zone of influence by superficial vegetation is much thinner than is true in the prairie soil condition. Coniferous forest soils have an even shallower topsoil condition, and soils are significantly less influenced by biologic material as you move further down in the soil profile. Parent material in Minnesota tends to be of four types, and by parent material, what I'm talking about is glacial material, debris that was brought from Canada, debris that was brought from the Dakotas, debris that was brought from Wisconsin as the ice sheet moved across the landscape. The first is what we can call glacial till. Glacial till is a catch-all phrase for the stuff that is picked up by the ice, carried inside of the ice, scraped along underneath of the ice, carried along as the ice moves across the landscape, and dozed across the landscape as the ice sheet moves from the northern and northwestern and northeastern parts of the continent down across the state. These glacial materials tend to be very poorly graded. In other words, there will be sand, silt, gravel, stones, cobbles, very large boulders, boulders as large as a school bus, all mixed in together in this glacial till material. Very, very poorly graded. It's not sorted at all. And it tends to be very dense because it had ice sitting on top of it for many different years, for a long period of time. The characteristic of the mineral material depends upon where the ice came from. That portion of soil that came from glacial till off of the Dakotas and central Canada tends to be more carbonate in nature, whereas the soil coming off of glaciers that came out of Wisconsin and Ontario tends to be tends to have a lot more granite and granitic quality to it. Glacial outwash is basically material that has washed off of the soil. It's very, very well graded. It tends to be pretty much pure sands and gravels, predominantly quartz in nature. And you can see here a soil profile that has a lot of glacial outwash material. This is material that's flowed off of the ice sheet as the ice sheet was melting, and this material then was flowing in the meltwater coming off of the ice sheet. Then we have alluvium soils, which are deposited by river streams that overflow their banks, and the material that's contained within the river then is deposited on adjacent landscapes. They tend also to be very sandy and gravelly, and oftentimes they will bury the original soil, and so you'll see a soil profile that looks pretty much like what we see on the left-hand side. Then finally, lacustrine soils are soils that formed at lake beds. They are lake sediments. They're generally well sorted, very fine textured. They have very low permeability. Water doesn't move through them very well at all. So these are the four principal parent materials that exist in Minnesota. Topography varies depending upon whether we're at the top of the slope, as you see on the left-hand side with the summit, or down at the bottom of the slope. Water moves downhill, and as it moves downhill, it carries debris with it, including mineral and biologic characteristics. And so the soils at the bottom of the slope tend to be deeper than those at the top of the slope. The soils at the top of the slope tend to be drier than the more moist soils at the toe of the slope. Soil survey manuals have quite extensive descriptions of the soil, and they will describe the soil mapping units quite carefully in terms of how did the soil evolve, what kind of geologic and biologic conditions existed, and they have a pretty nice descriptive characterization of the soils. The most important part of the soil survey manual for planning purposes are the tabular presentations of characteristics and suitabilities. These indicate such things as what kind of agricultural yields would we expect to see For example, how many bushels of corn per acre would we expect to see from an Ostrander soil? Uh, uh, how many bushels of soybean? How many bushels of oats, etc.? Also, what is the suitability of the soil for different kinds of recreational development? What is the suitability of the soil for different kinds of building site development, for use of different kinds of in soil sanitary facilities, septic systems, and such like that? Characteristics of water management, engineering properties, physical and chemical properties of the soil, and soil and water features. So these tabular representations are very important to planners because they tell us a lot about the soil and, more importantly, what the soil can and cannot be used for. And as you get into the soil survey database in this class, you will be referencing these attributes associated with water properties, etc., to make planning decisions. One of the characteristics that identified in the soil survey manual is the quality of the land for agricultural uses. And that's an attribute in the soil survey manual called prime farmland, where the USDA has identified how valuable the soils are as farmland, ranging from prime farmland to areas of statewide importance, to prime farmland if the soils were drained, to prime farmland if they were protected from flooding, to not prime. And as you can see in our study area, we have quite a few areas that are brown, a large area of soils that are of statewide significance. So we actually have quite a bit of significant agricultural land within our study area. Here, we've generated a map that talks about production values based upon the prime soil rating and the nature of existing cover. In other words, if we were wanting to bring more land into production, what is the value of that land based upon both its farmland class soil rating and its existing land cover? Land that is grassland and forms is much easier to bring into cropland than is shrubland or forest land. So we can define agricultural production values then that give us a sense of what are the most valuable lands from the standpoint of agricultural production.